Hello and welcome to everyone. In this presentation, I am going to talk about the idea 2020 that I have proposed, which is a sonic fire extinguisher, which is basically a fire extinguisher which uses sound as a medium to extinguish fires. So the purpose of developing this extinguisher is to put out fires, especially in space stations, where the properties of fire is very different from what it is in Earth, because obviously in space there is no gravity. So the firefighting mechanism that we have to deploy there has to be different from what we generally use on Earth. So if we discuss the process of spreading fire, there are three major components that require for the fire to burn, which is fuel, oxygen, and then heating element. So if the heating element is removed, then we can say that the fire would be extinguished. So that's where we are going to lay emphasis on, and that's how we are going to remove the fire. So the procedure of how we are going to use the sonic extinguisher is very simple. Firstly, the principle behind it is that as sound is a mechanical pressure wave, they cause vibration in the medium in which they travel. So the sound waves have the potential to manipulate both burning material as well as the oxygen that is surrounding it. The requirement of this the requirements needed to make this fire extinguisher can be explained in the block diagram, which I'm going to show you. This is the block diagram for the device. First component is the signal generator. The signal generator will generate a single frequency, because single frequencies cause larger vibration as compared to multiple frequency generators. So we are going to use a single frequency. So the signal generator would generate a single frequency that would be used to extinguish the fire. Then we need a filter. The filter is going to eliminate any kind of noise that is probably generated from the signal generator. The next module is the most important module of the block, which is the amplification block. The amplification block basically controls the gain and intensity of the sonic fire extinguisher. So basically the amplification block decides what amount of sound and what kind of sound would be generated so that the fire can be put out. So it is the main working block of the entire system. And the next is the output speaker, which would obviously give the sound output required as per the amplification block's direction, so that we can extinguish the fire. Now there are a lot of pros for this device, and there are some cons as well, which we are going to discuss in this segment. The pros is that it is a non-destructive method of fire control, so it ensures least damage to the surrounding areas. Traditional method of extinguishing fire involves using chemicals and toxic substances and foams, which may leave the surrounding areas unusable for some time or maybe permanently. But these extinguishing fire through sound ensure this that there is minimal damage to the surrounding areas. So, and also it would be particularly useful in extinguishing fire in space, which we discussed earlier, that the fire has different properties in space. So that's our main emphasis for this project. Also, with combining with swarm robotics technology, these sonic fire extinguisher can be used to nullify large fires such as forest fires and urban city blazes. And with how this can be done, I would be discussing this in the next segment, which is the feature enhancement. But first, let's see what are some of the cons of this device. Some of the cons are that there is a slight bit of complication which is possible, because in larger blazes there is a large amount of heat involved, and since the sonic fire extinguisher does not contain any coolant, so it may be able to extinguish the fire, but may not be able to prevent larger fires from reigniting once the sound is turned off. Also, one more important aspect is the kind of fire, the kind of sound what we are going to use. Obviously not all frequencies or all kind of sound would be able to extinguish a fire. While the initial research during the initial research, the thought was that the high frequency sound should be better equipped for extinguishing fires, but later it has been seen that this is incorrect, and that the low frequency, low decibel bass sounds are actually better suited for extinguishing the fires, and like they are more useful. Also, the speaker output that I mentioned about, that would be giving the output for the sound. I have a preliminary circuit drawn for the output, which I'm going to show now. So this is the output circuit diagram for the speaker, which we are going to be using. So the circuit actually comprises of an IC-IM136, which is also an audio amplifier and can generate a sine wave as per the requirement of the speaker. The LM386, which we are going to use, is a power amplifier designed for the use in low voltage consumer applications. The gain is set as 20 as default, but it can be increased to a maximum of 200 by addition of external resistors and capacitors at pin 1 and pin 8. So the final block, the output speaker block, works on Fleming's left hand rule. Actually, the magnet in the speaker is surrounded by a voice coil, which is made of copper. So in perpendicular direction, the electrical signal is then passed through the voice coil, which is induced by a magnetic field, which creates a force in the third direction. This is called the Fleming's right hand rule, which we all have studied about. So there is that. Also, on a concluding note, I would like to say that this technology, though new, but if it is harnessed properly, then it can be used in a variety of systems and can be very useful. For example, the swarm robotics. Swarm robotics is basically a technology where a bot or a robot is programmed to do a certain kind of task, and when the bot does the specific task, the other bots in the same ecosystem follows the first bot whatever he is doing, and they also continue to do the same task. So how we are going to use that is, we know that we can develop a level 5 IoT system for forest fire detection, which we have studied in our syllabus also. So the level 5 forest IoT system would detect a forest fire and would engage drones to go and put out that fire. Now the drones should employ the swarm robotics technology. This drone should be equipped with these sonic fire extinguishers embedded in them. So when the forest fire detection system detects a forest fire, the drones should be deployed. The drones should go to that area, and since the drones are operated manually or from a distance, or some drones are even operated automatically, so they would deploy the sonic fire extinguishers and the fire can be put out using this system. So that is one feature enhancement that can be worked upon based on this sonic fire extinguisher. And so that was all for this presentation. Thank you and have a nice day.